Hello, welcome to another session where we're going to play around with video filtering on the Pink system. See what we're going to do today. So, today we're going to actually do video filtering on the device. So first, it's building, and I want to make sure it fixes timing, so we're going to check the timing on this build, and then while this is building, we're going to generate an HLS kernel, a 3x3 kernel that we can do custom things to, and then we'll throw it into our pipeline. For the Sobel, make it an AXI register. Okay, yeah, we'll convert to AXI registers. That's what we'll do. Okay, so right now we're looking if we're meeting timing, and currently it's doing place and route. Take a few seconds, but let's review. So we have our Arty, and it's doing 1080p at 30 frames per second. At what's the clock rate for that? So we're doing at 74. We can easily do some processing at 30 frames per second, no problem. Everything easily meets timing. So, okay. So I have the system running, and we can load in different images. So we're going to start with our background image, and then I'll show you what images we have to test with. And today we're going to try a 3x3 kernel. Okay, once that's loaded, I can show you the main screen. I go to Droid Cam. So we go to Droid Cam, we have the Arty FPGA. So let's go and look at the screen that I don't have a capture device for, but so there is our first image we tested, and we have a few more test images. So let's go through them. We have Lena? What was it called? Two ends. Lena, so here's a classic Lena image. I did stretch it or resize it, so it's not the best, and there is the issue where we're only doing the top bits of the color, so we're only doing 12-bit color, not the 24-bit color that we could be using. And I'm just going to go through a few test images. I'll just go through the first 4 test images. Here's another one. This one, I don't know. It looks pretty good with a 12 pixel. I don't really see much else in it. I guess I'm kind of impressed by how well it looks with only 12 bits of data. So here's the next one. See how this one. I can definitely see the colors along the edges where this is a better gradient, and because we're doing the 12 colors, you get this kind of blotchy gradient now. Do this one. Do one more after this. Next one has much strong color palette. Yes, again, we can see kind of where the gradient isn't as smooth with the 12-bit pixels. Try this last one. This one actually looks like it's coming pretty well through. what is FPGA? So these are all images that we are pushing through our microblaze on our FPGA and using video DMA. I think that's cool stuff. Okay, so let's get back to looking at the code and seeing how we can do some fun video filtering on it. So let's go back to screen. Way. Okay, so let's see how Vivado is doing. It's currently in route design. It might be done soon. See how close it is. Yeah, it's doing an iteration. It'll finish there. So let's go ahead and start a new project. I'm going to call this a kernel. We're going to do a simple 3x3 kernel. Oh, no. A new project, not a new file. New project. Yeah, we're in a new project. We don't want it there. We want it. I'm not sure where things are located. HLS, sure, here. So we'll call it kernel. I mean, is there like already a folder for this? Kernel? We don't got anything right now. We'll have to add. We'll import it. 10 seconds should be fine. Go Artix. 7. It doesn't really matter. 4 and 35. So to complete this, we're going to grab some files I've worked on before, and we're going to convert them to use AXI Light interface. So we go to the pink video PR pink pipeline, the hardware, the software. This is software. So we're going to go look at the hardware. Where is my hardware? Here we go. Hardware. Let's go DRP, sources. I'm going to use the kernel. We'll have to bring this file and this file. So the goal here, this should all work. We don't need user data. And keep the single last bit. And the goal here is to take these kernel values and make it parameters here in the filter operator. Maybe pass them along here. Yeah, that should work. So let's open the raw in a new tab. We'll probably need that as well. Okay. So let's go to HLS, new file. Sure, we can go here and we'll go to function.cpp. It's not happy because there's no H file, so so it's a new file. Here we func H. Here. Okay, this is happy now. Let's make this one user bit. And we don't need to worry about that stuff. Define buffer is good. We're not going to do any of the command enable stuff. Okay. So we need this kernel. We're going to stick that here. Kernel. And I guess we could just then like sign it. Let's just have it be a passive for this. Right. We have the shifter and limiter and stuff like that. Shift value. Be happy with it. These are all chars. Okay, so now we're adding the parameters and hopefully these give us a good default. Okay, now let's open up the file, that other HLS file. So let's go back to stream, go back to HLS, go look at the pixel impact CPP. Move that to a new instance and bring that over here. Okay, so we have okay, and then we need where's this file? Kernel shift value lower limit upper. Okay. And let us work on that, see how this is going. Let's look at the report, shall we? Is that an issue of timing? Can I reopen, reload? I fixed the timing on this guy. So we're gonna see what was the issue of the timing. I thought I fixed it. Okay, so that's working. Oh, we gotta specify top function. We want the Sobel filter dot operator. That's not fair. Project settings. And greater. Okay. Okay. Building. Let's go back over here. And can we see where this is coming from? So it's mode register in the pixel unpacker. I'll look at this. This should be the control clock, the app clock. So look at that. Maybe my HLS didn't get. Go solution, implementation, IP, HDL, VHDL, pixel unpacker, edit. I have a clock and clock. So yeah, I don't want this register logic. This register logic and the here. See, it's on the wrong clock. Yeah, let's go have to look at that one. See if this one builds. There's an error for this one. Okay, I wonder if I can figure out how to do HLS axi byte registers default values. I just have to do it in software and not worry about it. I don't see anything. Okay, so if we look at or if it has a default value. How are we able to keep our... No, it has to read the thing. It's nasty. So let's see. Go back up to having that static char kernel equals kernel 9 equals 0 0 0 0 1 0 0 0 0. So we're gonna have what, char kernel index 0 and char kernel value 0. And index value. Is there a parameter I can put on it so it doesn't, if we go directives, I can make it modify directive. You can just say kernel index is kernel value. Or we could have, okay, let's see this, and then we can try something else. Let me open another Vivado HOS thing to look at the other work. Get rid of this registering. Open pixel unpacking. Okay, we're gonna go back a few steps because and then we're going to add the shift value upper limit that runs pixel unpacking. Have this register logic. Don't want that and that one. So um, Okay. Build that. So we're doing 1 1 there. So we're gonna add these 3. Oh. So that get rid of this, and this function we'll worry about shift value lower limit upper limit. They're all inside. Go down here to where this function is called. I'm going to do shift value lower. Let's see what that looks like. So let's look at our VHDL and see if it has register logic down here. So what's this? HLS remove register logic light. So if we do add register, on that one. Okay, we're good here. We didn't say which interface that was. Here. Wait. So you're doing good cross-clocking domain, is it? So the HLS axi light cross clock. Guess we could do that, just have it run on the same clock. I mean, that would probably be a straightforward solution here. Okay, so try that. I'm not going to give you a separate clock. Take that. Okay, we're still doing good here. Now, find char kernel index 0. Kernel value. Oh, I bet I need to do it like, oh, it goes to the whole indexing. Maybe if we do this type of but if we do something like this, if there, and we put in kernel index, this is why in kernel value. Then I don't anymore. Running on slow enough. We can get this all matching. Okay, so let's build that one. How about our other one over here? Yeah, there's no additional clock. It's running on the main clock. Yeah, let's go ahead and just do that. We'll export that to our project and rerun it. What's our error here? Okay, so this one works. That works. Now we do kernel index equals kernel value. This will screw up our timing because certainly look at we have a interval of 1. That's the most critical portion of this. Now if we do this, what it's going to do is going to cause a memory to be created in the HLS. It's kind of annoying. Okay, yeah, so it causes this whole indexing thing. But what if we can do a directive on kernel? So where is kernel? Kernel is right here. Insert a directive. It's the partition. We do a complete dimension 1. Add that to the source file. Add that to filter off. Was there something else we could do by directive? We can't do like there another directive we can add to kernel? Array map, array partition, resource, or we want array map, shape, set, table, stream, source. We're used to have like VRAM. I guess we have VRAM, dual port, VRAM, multi-port, distributed RAM, ensure with usage. Yeah, we'll try these things later. Okay, so we've made it so it's partitioned completely. Small enough that shouldn't be an issue. Okay, that worked. Doing the complete partition. Okay. So implementation, we're good there. Yeah, let us export this guy. We're gonna export him into VHDL land. Vendor, AEW, library, description, display name, kernel. Yeah, okay. Where's that? What's used? Implementation, go drivers, switch operators, data now, hardware. Oh, let's try one more thing. We do a char, and we do a kernel right there, right? And add it as a value here. Get rid of that one. This work as well. Here's that one. We gotta export this. Error located. Can we do C++? C++ default array as parameter. Okay, so not says to do a shot. Oh, testing unsigned char kernel limits equal. Do that. Me not knowing exactly what we're doing. Okay, so setting up the default value for the kernel. In truth, I don't have to have it, but I'm curious to have it. Okay. Worked. Okay, and try packaging it. I don't see any default values per se. Let's see. Go to this. Oh well. Just gotta make sure we put in those default values. So we got that, we got that. Let's add this to our value here. We're gonna refresh the catalog. Catalog. So let's add the kernel. Add people diagram. We're going to do it after act. We're going to run a connection animation. Death is going to be DVI clock. Rerun this. Upgrade selected. Yeah. We'll skip for now. Let's go. Verified everything is connected happily. That's one. There. The address editor. We have the kernel. Filter operator was called A3. So we'll have to set that up correctly. But there we go. We have our filter operator. Maybe we can do a bigger kernel. Have some fun stuff. Okay. Yeah, let's generate that bit stream. Okay. Okay, the pixel unpack. Master 4. Disconnect that pin. Connect that pin. We're now API clock. Okay. should actually, validate this before we go too far. That's exactly what I want to see. Rerun. So let's go look at that kernel filter again. Okay. Oh, I should change the resolution up, but oh well. So that's all happy. Let's go ahead and generate the bit stream there. Let me go back here to this one. We have a fun issue where if we don't rotate these lines like this, things don't get happy. So what we're going to do is we're going to try to do RGB, and we want to do, so we have 3 lines, line buffer set. And line RPG insert directive map, I want to partition this by line buffer size. That would be 1920. So the idea is we did this. All we're gonna do, go through all of these. Okay, and then we're gonna remove these. Save that. Okay, now let's try running this and see if that partition worked. Said line buffer. What are you angry about? The array does not have dimension 1920. Oh, dimension 3. Let's see if dimension 1 works. What I'm doing. Okay, we've gone to the synth page. Seems like a lot more than I used to. Three. Okay, let's see if we get rid of this correct, right? See what happens. We have 2 and we have memory 1. So do this. Now, let's try to create one thing out of this. What we want to do is we want to take this right here. It's going to be temp. To temp row 0. So unsigned sharp row. To all reality, it don't need to be. Do 1, 2, 2. Now, let's copy this real quick. Closing. I need to find out what I did. That's good. Let's go. Okay, we have a 3 here instead. See if the memories were split up. The memories were split up. Maybe we can figure out what the issue is. I'm doing. Resource. These guys. We have the right. Read. We find where this go to source. Offline. R1. Resource. 95. 94. Oh, did we not? And get rid of that value. Synthesis. Okay, we're routing design. Maybe we can get that filter up and running before it's too late. Okay, so we still have analysis. We want resource view. We want memory ports. Always what causes issues. There's 2 reads. We have read here and read there, read there. Right there, there, there. Oh, it's a railroad too. That's garbage. Let's try. Doing that. This is remove the interdependency, saying we don't need you to worry about the values between in the middle of a function call. Okay. Oh, we made it. Cool. This way we could actually be able to increase the parameters. Like we could take this value and maybe do a quick for loop here or something like that, so we can make that much bigger and do a larger window size. Okay, we'll look at doing that probably next week. Well, first we want to see if this is going to finish. How close are we to finishing? Routing is done. Okay, routing is done. And then we import the hardware, then update the software, and then write a. I have to write 2 values to that one kernel module to get it working, and we can do that pretty easily. Okay, whatever. I'll just use this as a reference then. You're going to destroy the implementation IP every time we do this. Here we go. Maybe that's the same with our current solution, the way we've done it. Yeah, it looks the same. So, we want to write upper limit to 255, and then kernel 4 we want to be 1. So we want to write to 48 and 20. Yeah, I can just do that quickly in our yeah, maybe we can just do that. This is very good stream. We'll program it. We'll run the software we have. That should be cool. Okay, let's open the hardware manager. Just go ahead. Oh, that's what to do. Understand. That's what we want. Let's go ahead and program that with what we're doing here. Program that. Now program. So we're going to go to our SDK and we're going to run it. Now it's running. And if we go here, we should have probably a black screen. It's active, we have a black screen, okay. So let's go here, and we want to go to go confirm which address we want to go to. 44A3. So we want to do a memory write of 44A3 0020. We want to say 255. And what was the other address we want? The 48. 48. I'm gonna write a 1. So now we have a grayscale image. Okay, cool. So that's worked. Let's put a test image in because this is my favorite. And now we're going to do an outline configuration. And we want to, I can go to the website, go to kernel, review raw because it's going to take forever. www. HTTP, this website right here. Okay, so we have a sharpen. Let's do an outline. They're one of my favorites. So we're gonna do -1, -1, -1, 8. Okay. Oh, you can't see the image right now. It's basically doing grayscale conversion, but let's get you looking at it. Seeing what we nice good cam over here so I can see as well. Take it back. Okay, so there is our grayscaled image. Let us do some processing now. So what we're going to do is we're going to do, if we look at the HLS right here, it's going to be port 28, 30, 38, 40, 50, 58. So it's going to be every 8 starting at 28. So it's going to be interesting. We're going to see the image change while we do this. So we're going to start at 28 and do -1. Yeah, that's already cool. Let's go ahead and go 48 and put an 8 there. Got nice and vibrant. Put a 30, 8, 40, 50, 58, 60, 68. See the last one? Okay, so we're here, we're doing an outline. You have to fix the orders of that. So let's see, is there a more impressive one we can do real quick? Outline, sharpen, identity. What we did. Let's do a right Sobel. Okay. So it's gonna be -1, 0, 1, -2, 0. Okay, we're gonna do a right Sobel filter. Starting at 28. I'm gonna do 28. 30. And then 38 is gonna be a 1. Then 40 is gonna be a -2. And then 48 is gonna be a 0. 50 will be a 2. 58 is going to be a -1. 60 is going to be a 0. And 68 is going to be -1. That is not what I expected. Let's do a memory read, shall we? Of 44A30, 28. I need to read 14. We got 60, 0. We got 8, 0. 30 is 0. Maybe there's just so many edges in here. Let's try a different image. Maybe we need to shift it more. Okay, so if we read, we have, and if we go to HLS, function, finding the y, not the x. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, here 28, so that would be negative 1, 0, 8. Okay. So let's try the shift value. Shift value is 10. Right. And that's not really working. Huh. Cell bell is not working like I expected. Take a look at our cell bell. Became video notebooks. Yeah. Source. Cell bell. What are the initial configurations for this cell bell? And what's the shift value? Lower limit, upper limit, cell bell weight. Okay, let's try a lower limit of 100 and upper limit of 200. And our limits are, lower limit is 18 and 20. So if we make 20, 100, and 28, 200. Lower limit is 18. No. So this is supposed to be 1. 20 was supposed to be 200. I think it was supposed to be 18 was supposed to be. Getting the edge detection. That's negative 1, 1, negative 1, 1, cell bell. Get value to edge weight shift value. Yeah. So we're expecting kind of thing here. What I can think of is, let us try increasing let's do 40. If we do a shift value of what, negative 4, and then what, 50, we want to see positive 4. Yeah, it's not seeing the edge detection I was hoping for. Well, we'll have to figure that out, but we're operating on the system. Well, I think that's good for now. I'll play with this more. Post this video on YouTube. Thank you for watching. Hopefully we can I can figure out what's wrong with that cell bell and show it next time. Well, see you guys tomorrow. Bye.